So I'm now going to go to our next question, which was sent via social media on the Facebook page of Mindset. Let's go and check what this question is all about. Right, so question 2 says to us here, in the diagram, there's a point D and B and C, right, are points in the same horizontal plane, right? Now, important, very important, we're doing 2D and 3D. There's the horizontal plane. When we talk about the horizontal plane, we're talking about the ground surface, right? There's going to be the vertical plane, which is when you're going up now. Do not confuse those two planes. When you treat them separately. There are connections, maybe connecting lines or sides that are common between the horizontal plane as well as the vertical plane, right? Those can help you to move information from the horizontal plane to the vertical plane or the other way around. Please keep that in mind, right? Okay, fine. So the AC is a vertical pole, and the length of the cable from D to the top of the pole A is P meters, right? So if you look there, you'll notice that we were told that that line AC is actually a pole. So imagine this as if it was a pole of some sort, right? Standing upright. And then there's a cable that moves from A all the way to D. That is basically a cable that you're simply looking at there. Try to imagine this, guys. Very, very important for us to keep this in mind. Okay, it's P meters. Now, AC is perpendicular to CD. We are expecting that to be the case. We are expecting AC to be perpendicular to CD, right? Angle ADC is equal to theta. ADC is theta. We can see that it is there at the bottom, right there. That is called the angle of elevation, because if you're standing here and you're looking up, you're actually looking towards the top there. That will be regarded as the angle of elevation of A from that point D there. So that angle of elevation is theta, and then DCB is 90 degrees minus theta, DCB is 90 minus theta, and in addition, you'll see that CBD is 2 theta. So CBD equals to 2 theta. That's another angle that you're looking at here. So very important. Now, you'll notice that this plane here, which I'm now going to color, is what we would know as the vertical plane, the horizontal plane, the flat plane on the ground, and then it shouldn't be confused with the other triangles that you're sitting with there. Right. Now, the first question is asking us to prove that BD is equals to P cos theta divided by 2 sine of theta. Right. Now, when you're dealing with these questions, guys, here's a secret to acing this all the time. You're going to look at the side that they're asking you to find, right? And then you check in which triangle does this side belong. This is just a combination of triangles. There's nothing special with 2D and 3D. It's just a triangle and another triangle and another triangle. You're just starting or trying to get to solve triangles that are combined. Now you look for the triangle that you can start with. The best triangle that you need to use is a triangle that has a minimum of 3 given things, not things you can find on your own. So you check a triangle that has got 3 things on it. That is the triangle that you have to always begin with. Right, so let me go and find where BD is. If you look on the diagram, you'll see that BD is lying right there at the bottom. There's your BD right there. We're happy to see that. Now, for me to be able to work out the length of that side BD, right, I need to use triangle BCD. But the bad news about that triangle, if I isolate that triangle and I draw it on its own here, we are looking for that BD. We see that this is what the examiner is asking. We've got 2 theta here, right? And we've got 90 degrees minus theta. So this triangle, sadly, does not have enough information for us to work out the length of BD. So abandon mission. Now I'm going to go to try and find, is there any part in this question that has at least a minimum of 3 things? And you will notice that the triangle on the far left, this triangle here on the vertical plane, this one that you're looking at there, has a minimum of 3 things. And you need to always try and isolate those triangles so that they assist you to see what you can do with what is happening there. We've got P here in this triangle. We don't know the length of the pole. We've got theta here. Already I've got a minimum of 3 things. If you look there, I've got this thing here, I've got the angle here, and I've got 90 degrees. So this looks like a good triangle that we can begin calculating from. And when we calculate that, we are going to use that triangle to figure out the length of CD. We're going to try and figure out the length of CD because that CD is a member of the triangle CDB that is lying on the flat plane, and that will help us enrich that triangle that is at the bottom, which contains the side we're basically interested in. So if you look there, I'm actually going to find that length, and when I find the length of CD, that will enrich the bottom triangle that you guys are sitting with there. Very important for us to keep that in mind. So I'm going to manipulate the triangle on the far left, use it to find CD, and that will enrich the triangle at the bottom that I'm looking at in order to help me find the length of BD. Right, so let's begin. In that triangle that you're looking at, in triangle ACD, right? I'm going to write this here. In triangle ACD, what can we do there? The upright triangle that you're looking at, ACD, I can use the cosine theorem, the cosine rule, or I can use cos from SOHCAHTOA because that's adjacent side that I'm looking for in white divided by the hypotenuse, which is your P length there. Right, I'm looking at this triangle here. I've got P here, I've got theta. I'm looking for this side. Very important. So I'm going to say the cosine of that angle theta is given by the adjacent side. What is adjacent to the triangle? The adjacent side is the line CD there. So I'm going to say the adjacent side CD divided by the hypotenuse, which is P. By cross multiplication, our CD comes out as P cosine of theta. Right, now I found the length of that side, which is good news, because now when I go to the bottom triangle that the examiner is interested in, the one that you guys are looking at now, that one with C here, that has got D here, and that has got B there, I know for a fact that I just found that the length of the side CD is as good as P cos theta. So this is P multiplied by the cosine of theta. I have 2 theta here, and I was told that this angle is 90 degrees minus theta. So I have got enough information now because I've got 3 things that I can start using to figure out the length of BD. So I'm going to use now in that triangle the cosine rule. And what does the cosine rule say? The cosine rule not going to work in this case because of the fact that we don't have 2 sides and an included angle. The best rule that we can use, since we are looking for that, is the sine rule in this case. And according to the sine rule, BD divided by the sine, right, of 90 degrees minus theta is as good as that side CD divided by the sine of 2 times theta. And then we're looking for BD. We're going to make that the subject of the formula. So your BD is going to just simply be, when you cross multiply that one part, just cross multiplying this, what exactly happens there, you will notice that you're going to now get CD. But we know that our CD is P cos theta, so I'm going to write it as P cosine of theta multiplied by the sine of 90 degrees minus theta. That sine of 90 minus theta can be written down as the cosine of theta as well, using reduction formulae skills. And the denominator is a double angle. That sine 2 theta is a double angle of sine, which can be expanded to 2 sine of theta multiplied by the cosine of theta. So we did a lot of double angle and compound angle formulae. This should actually make sense to you. And when you cancel that out, you'll see that cosine can cancel cosine out, and then you are left with the fact that BD is P cos theta divided by 2 sine of theta, which is exactly what the examiner wanted us to prove in the question. You can then conclude and say, therefore, your BD is P cosine of theta divided by 2 multiplied by the sine of theta. Very powerful. Right. Now, in conclusion, the last part of the question, we are asked now to calculate the height of AC, the flagpole, if theta is 30 and if P is actually 3 meters. So theta is 30 degrees and P is 3 meters. So let's go back and see what we can do here. Let's go back and see what we can do here. If we clean that up, right? We want the height of the pole. We want the height of the pole. So we were just told now that this is actually a straightforward question because we were told that this is actually 3 meters and we were told that this angle here is actually 30 degrees. So I can apply my trig ratios according to what we know. The sine of 30 degrees there, the sine of 30 degrees is equal to the opposite side, which is that length AC, divided by the hypotenuse, which is equal to the P value that was given to us as 3. And if I simplify, my AC is going to come out as 3 multiplied by the sine of 30 degrees. And if you simplify this, we know that the sine of 30 degrees is simply 1 over 2. So this is going to be 3 multiplied by 1 over 2. And the final answer comes out as 3 over 2. And that will be the solution to this question. So a very powerful question indeed. Thank you for sending us that question. I hope you can see the most important thing that I want you to take home from this one is that when you are dealing with a lot of triangles that are happening here, look for the one that has got a minimum of 3 things. Use it to find the common side between 2 triangles. You'll notice that there's a line that links 2 triangles because you want to transfer information from one triangle to the other triangle. And once you know which rule to use, remember the cosine rule is only used when you've got 2 sides and the included angle, or when you've got 3 sides. Other than that, you always need to know that the sine rule is going to be the rule that you're using in order to figure out whatever you are looking for.